Ask My Instructor 4.2.31. Perform a first derivative test on the function. Locate critical points. Use the first derivative test. Then identify absolute min and absolute max. Our first objective will be to find the derivative of f. Before we find the derivative of f, I'd like to find the derivative of radical 144 minus x squared. First, rewrite the radical using exponent notation. Then, use the power rule version of the chain rule. From here, we're going to take the derivative of 144 minus x squared. When we do that, we get negative 2x. Cancel the 2's. Bring the negative to the front. Then, put the factor with the negative exponent in the denominator and use radical notation. When you're done with that, you'll get negative x over radical 144 minus x squared. So this was just a preliminary step, and we're now ready to find the derivative of the function. Set up the derivative of the function by using the product rule. Now you can see why we did that preliminary step. The derivative of radical 144 minus x squared is negative x over radical 144 minus x squared. We're going to use that knowledge to find the derivative of our function. So do the substitution and also use the fact that x prime equals 1. When the dust settles, this is what you will get. Bring out the negative and also do the multiplication x times x. And so we are done finding the derivative of f prime. Finding the derivative of f, which is f prime. Having found f prime, we locate the critical points of the given function. As you know, we use the derivative to find critical points. We first ask, is there any place where the derivative does not exist? Well, for this function, the only place where f prime does not exist is at the endpoints negative 12 and positive 12. Recall, critical points must be on the interior of the interval. So, even though the derivative does not exist at negative 12 and positive 12, we disregard those as critical points because they're on the end instead of on the interior. Continuing our search for critical points, we next ask where f prime equals 0. To do that, we set the derivative equal to 0 and solve for x. The easiest way to solve for f prime equals 0 is to write f prime as one quotient rather than the difference of two quotients. We will write f prime as a single quotient by rewriting the first term so that it has a denominator of radical 144 minus x squared. Do that by multiplying the first term by radical 144 minus x squared over 144 minus x squared. And this is what we get. Okay, we got a little bit of cleanup to do. Simplify the first term. Notice that I have radical 144 minus x squared times radical 144 minus x squared in the numerator. In the denominator, I have 1 times radical 144 minus x squared. So my first term is simply 144 minus x squared over radical 144 minus x squared. Next, we subtract. Since they both have the same denominator, we can just look at the numerators. 144 minus x squared minus x squared, which is equal to 144 minus 2x squared. We are now ready to set f prime equal to 0 and solve. The quotient is equal to 0 when the numerator is equal to 0. So to solve for x, for the quotient, we need only solve 144 minus 2x squared equals 0. First, solve for x squared. X squared is 72. So x is plus or minus radical 72. Now radical 72 is 6 radical 2. Notice that 6 radical 2 is about 8.5. So both 6 radical 2 and negative 6 radical 2 are in the interior of the interval and can be counted as critical points. The function has two critical points, 6 radical 2 and negative 6 radical 2. Next, we use the first derivative test to locate the local max and local min values. For the first interval, I use x equals negative 10 as the test point. F prime of negative 10 is negative, so the function is decreasing on the first interval. For the second interval, use x equals 0 as the test point. F prime of 0 is positive, so the function is increasing on the second interval. For the third interval, use x equals 10 as the test point. F prime of 10 is negative, so the function is decreasing on the third interval. Putting all this together, the function has a local min at x equals negative 6 radical 2 and a local max at positive 6 radical 2. Next, identify the absolute min and maximum values of the function on the given interval. We have two endpoints, negative 12 and 12, and two critical points, negative 6 radical 2 and positive 6 radical 2. F of negative 12 is 0. F of positive 12 is 0. F of negative 6 radical 2 is negative 72. F of 6 radical 2 is positive 72. So we have an absolute min at negative 6 radical 2 and an absolute max at positive 6 radical 2. My math lab did not ask you for a graph, but I thought you might want to see one. As you can tell, the function is equal to 0 on the endpoints and then has a absolute min at negative 6 radical 2 and an absolute max at positive 6 radical 2. Take care and have a great day.